Okay, so the easy ones. For number one, what's wrong with A? What's wrong with A for number one?
It can't be equals.
Can't be equals is fine. What are our options? Everything else is fine there. What about B? Those should be the same number. C. Nothing wrong with that one. What about D?
Different numbers and the second one.
And what about E?
It's P times.
So those are just making sure that we get our rules of same symbol, parameter, null is always equal, alternative is always less than, greater than, not equal to, that kind of thing. Alright, so number two, researcher thinks that if expected mothers use vitamin pills, the birth weight of the babies will increase. What's important in that first sentence? What's important in the second sentence? Two things that I would want to mark.
Average and
So my null hypothesis is going to be what, because I'm dealing with averages? This always has to be, and the claim is, so this is one of those where nobody said they are 8.6 pounds, like it's not like initial, it's not a claim, but that was kind of the one where it's the past one is, I guess. And then we are claiming that this group, under whatever it is that we're dealing with, would say that these would greater than, because they'll increase from where they were initially. Engineer hypothesis is that the mean, there's telling me that, can be decreased in manufacturing process of compact discs by using robots instead of humans. The mean number of defective discs per 1,000 is 18. So our null hypothesis would be what? What symbol? Mu, because it's means. This has to be. And then this would be, it's technically 8 discs per 1,000. But depending on how you defined it in the problem, you could have defined it as number per 1,000 and written it as 18 discs. My alternative hypothesis here would be what instead? Less than, because decreased. So I'm not making you in this worksheet define your parameters. But if we defined a parameter here, we would say let mu be what? Average birth weight of babies. It didn't say anything more descriptive than that. Here would be let mu be the mean number of defective discs per 1,000. So in your homework, you're actually going to have to write that part of it. So I'm not going to waste my time to do it for the worksheet, but make sure you are also defining it for your homework. A psychologist feels that playing soft music during a test will change the results of the test. What's important in that first sentence? What does that mean to me? Not equal to. So I think it's going to be different, but I don't know which one, so I just go with not equal to. Psychologist is not sure whether the grade to be higher or lower, which says the same thing. However, in the past, the mean was 73. So my null hypothesis is what? And probably should be some units, but this is one of those weird ones where that doesn't really make sense as close as we can get. Our alternative hypothesis is instead going to be explain why the statement x equals 50 is not a legitimate hypothesis. Be a parameter, not a statistic. Okay, so this is going to look like a more realistic problem that you'll get eventually. So I'm going to talk through this whole thing. A production line produces rulers that are supposed to be 12 inches long. Might be helpful, might not. We don't really know yet at that point. A sample of 49. This is my what? I didn't expect you to write all this necessarily down the first time, but you should think through it this way. Other rulers had a mean of 12.1, so that's my, and a standard deviation of 0.5. Because it's still of that sample. The quality control specialist responsible for the production line decides to do a hypothesis test at the 90% significance level to determine whether the production line is really producing rulers that are. So that is kind of confirming it for you at the end, but this problem was not super specific. So the claim here, even though it wasn't ever really written, would be that what?
The rulers are 12 inches.
And so what would I put symbol-wise? We're testing in this one instead. What? Because we want to know if they are or not. So we just go with that. And so this is your X bar, so you don't want to use your X bar here. A sample of 20 OU freshmen. So 20 is my what? Had a mean GPA of 2.8 over all their courses taken at their first semester at OU. Does anybody remember what that symbol is? That's an S squared. Perform a hypothesis test 95% level to determine if the first semester GPA of all OU is less than. So this is one where there's no initial claim at all. It's just what I'm testing. So this one, it kind of makes more sense to say, well, what is it that I'm testing? Which is what? What is the direction that I'm testing? I think it's less than that.
Oh, you're doing your HA.
Which means by default, that would make this what? So that's what I was saying initially when it didn't make sense because you didn't know what I was talking about. I call this initial claim, but it's not always literally the claim that is made in the problem. Nobody ever claimed that it was 3.0. We're just testing to see if it is significantly less than that. And what would be my parameter here if I defined it? I would say let mu be the what?
Average GPA
Of in the first semester. Yep. So with this one, a survey of 4,000 people. So that's our what?
and
In the U.S. finds that 2,856 of them believe that daily weather reports are totally useless. What do you think that is? Because that's our number of successes. What would I use X and N to find?
I thought you were about to use
So I would use that if this were really a problem.
Oh, I thought he had what? 2, 8, 5, 6, 7.
Is that a performance? Yeah. Given this data, perform a 95% hypothesis test to see if more than half. What did that problem say? Two things. What did this sentence say? More than and half. So my null hypothesis is what? What symbol? P, because I'm dealing with proportions now. Well, this has to be. And what is it that we're testing against? As opposed to what we just said there, so I'm putting what in between instead. Because we want to see if it's more than half. And I think that's the only proportional one I threw in there, I think. And just like the last couple chapters, at the beginning like this, I'm throwing proportion stuff, we're actually going to go through and we'll do just means. We'll do all of those, and then we'll switch and we'll also do proportions. EPA reports that exhaust emissions for a certain car model has a normal distribution. Well, that's the kind of thing that I should mark if I'm reading. It's not a problem I'm dealing with right now. With the mean of this. So what is that for this problem? That's saying the EPA reports that overall it is. So that's because I didn't have a sample that I'm dealing with, which means this is my car manufacturer claims that their new process reduces the mean. Well, mean reduces for this car model. Simple random sample. What is 28? Is taken and the mean level exhaust. I don't know what it is. I record that. I just didn't write it down. So what is the null hypothesis? And then an alternative would be so I would be using all of those other numbers if I were doing the full problem, but right now we're just saying what's null and alternative hypothesis. Eventually, I'm going to be using all those things that I just circled, but we're just not there yet. A credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage. What's important there? What?
Increase.
Which has a current mean of 2,500 per year. So what is that you think is? They gave a free miles to, there's a random sample, there's my, and that group of little n is found to be, well, it flat out tells you sample mean. So my null hypothesis in this one is,
And there's a population.
oh, and so that's my what? Talking ahead here, which is not where we are today, I gave you S to some extent and X bar. What kind of problem is this going to be? If I have this from last chapter,
Over the T.
and then if I give you this instead, what kind of problem is it going to be? So that relationship works again. So if you have sigma, you use Z. If you have S, you use T. So my null hypothesis in this problem is
Mu equals 2,500.
as opposed to my alternative, which is going to be
Mu is greater than.
if I draw this one, just because of that right here, where am I going to shade?
Because of what?
All because of this, where am I going to shade?
Right.
We're not there yet, but just tying things in from what we did today. Where would I shade here? To the left, because it's less than. What about here?
Everyone but.
So when we dealt with it before with confidence intervals, that's what our confidence interval looked like. So that's what that one.
If it's just one line, then what do we do?
If it's what?
If it's just one little line, then
You're gonna only get one and you're flat to both sides.
No, yeah, but like, how do we make it? Like, if it's k equals 12, how do we make it so that it doesn't look like the whole thing is?
Once you get to a problem, you're not gonna have that shit. And then the last one, the entire telemarketing sector, employee satisfaction rate with their jobs is, well, it gives you mu, it gives you sigma. They believe their policies are significantly better at keeping its telemarketers happy on the job. 25 is my what? And they had a mean of this, so that's my. So my null hypothesis is
Mu equals 65.
as opposed to my alternative hypothesis, which would be, the problem did not ask you this. I do not want you to do this on your paper, but we can think through this. Eventually, we're going to get down to saying P parentheses, what letter symbol here? We want to know that X bar is what? What was our X bar? So let's convert that. So what is our value?
70.
Minus what's our mean? How do I find my standard, or how do I find what goes here? What does that equal? And we don't have S this time, we have sigma, right? So sigma over square root n.
Yeah, but do we have sigma X bar?
Or that's what we're putting here. So what is sigma? What is square root n? And I could write that there. But so, is it okay to just plug it in there instead of throwing off the side? Yeah. 2 point what? And if I were to continue doing this, P parentheses, Z is greater than 2.5.
Wait, I'm looking for X is supposed to be.
If I drew my graph, 65 would be here, and 70 would be somewhere over here. And so that's where this one goes. And then somebody typing it in really quick, what do you get when you, what's the probability of over 2.5? So that's going to happen less than 1% of the time. So does this company have convincing evidence, like a court case, to say that they keep their telemarketers happier than other companies? We'll tie in that part. If this is saying hypothetical, if our company really was like everybody else, it would be so rare that this would happen that it would happen less than 1% of the time, which means what they said is not right. So I'm going to bring in with my next sheet.